Welcome to Densify Talks. Thank you so much for joining us. My name is Brian. I'm the producer of the show. And on this episode of Densify Talks, Andrew and Hitesh Chitalia from FactSet discuss the evolution of the cloud and the best practices that have emerged in resource optimization. Having been involved in cloud from the start, Hitesh shares some of the aha moments that he had along the way, including how to effectively engage engineering teams, the importance of data-driven approaches, designing for elasticity, and thoughts on where the industry is going. This is going to be a good one. Here is your host, CTO and co-founder of Densify, Andrew Hillier.
Today, we're excited to be joined by Hitesh Chitalia. Hitesh, why don't you tell us a little bit about yourself before we begin?
Sure. Thanks for having me today. Really appreciate the time taken today to allow me to speak about cloud optimization. My name, again, as mentioned, Hitesh Chitalia. I've been in software for 30 plus years. Started out as a software developer and software engineer. Made my way up through enterprise architecture. Started to work in the AWS cloud space 12 years ago when it first came out in about 2010. And I've been dabbling in cloud since the last 4 years. I've been working in the cloud optimization space for various companies. And there you have it.
So you have a ton of experience in this area, and it's interesting when you say 12 years ago, because I remember those days when cloud was very early. I mean, it wasn't at all obvious what was happening or where it was going to go. The role of cloud optimization probably didn't exist. So if we rewind way back there, I mean, maybe tell us a bit about your first experiences with the cloud when you first started running workloads in it, and what those early challenges are versus what we're trying to solve today.
Yeah, early days, it was all about just trying to figure out what was possible. We called it the art of possible, right? You can spin up a machine without really requiring backend IT support, which would basically take 3 months to get you a VM. You have to fill out all these forms and really slow things down. In this new cloud world, you can just throw a credit card out there and get an EC2 and set up some networking and you're off and running. In those early days, it was all about just what can you do on the cloud? What's possible out there? What can we bring into the cloud that would help speed up development and delivery to our customers, right? So we wanted to basically get something up and running. You might want to experiment. A lot of it was just really about experimenting or doing proof of concepts. So we would just quickly spin up a machine or two, throw some of our test software out there, run the tests, and then we tear it down. We learned early days about paying as you go. So if a machine was running and you just kept it running, you were going to keep paying for it. So we learned early days to just say, hey, let's just turn this off and save a few dollars here. In the early days, it was all about just turning things on and off and making sure that you didn't leave something behind. That's where we learned a lot in the beginning about cloud, about how it can help business, how it can help product development, and how we can test things out as engineers. We got new software, new coding techniques, new programming languages, anything like that. Didn't have to wait 3 months for a machine anymore. Changed the paradigm.
I recall those days, it was almost like you're free. You're free from the corporate machinery that slows you down.
Right.
But with that freedom came these big cloud bills and like you said, people leaving things turned on. So the early challenges that were interesting in terms of, turning things on and not turning them off. And then somebody sees the bill and kind of freaks out. And so in the early days, there was a big focus on the bill. I assume you kind of went through that process as well of starting to figure out who's spending what and getting that under control.
Yeah, and that's one thing that has not changed even today. Every now and then you get an email and sticker shock. Wait, what happened? What was left running? Right. So it's just a different scale. And so in the early days, you tried to limit who had access to the cloud and you limit what you could do in the cloud. And you tried to put those controls on there, but those controls they're basically again putting chains around something that's already out and available, right? If you're in marketing, if you're in any other non-IT oriented organization, you can just have your own IT space to go and run your own software. So you try to corral who has what account. You try to corral from a billing perspective. You try to centralize billing just to get a sense of who's doing what and how much they're spending. Again, relatively speaking, in those early days, they were small. At least in my experience, smaller spends. Today, they're much larger spends. You have many, many accounts in a given organization. You have many small engineering teams working on their own thing, and they're all just spinning things up and could be leaving things on, or maybe they selected a service that's very expensive. And so there's a lot of that going on, right? Where you spin up a machine or an environment to performance test, and you set up these heavy machines and you forget. Even today, I hear a lot, oh, why is this machine still running? There's some bill that comes up, or you see some report that, hey, this machine is still running. You go to the engineer or the engineering team, say, hey, is this still supposed to be running? And they're surprised that it's even still running. You get a lot of that still, even today. A constant battle of trying to turn things off, trying to just raise the awareness of, I won't call it runaway spend, but surprise spend.
And interesting, because I think cloud from the start had the promise of elasticity, and it's really efficient if you can use whatever resources you want. But what comes with that is you should stop using them if you don't need them, and that's what people were particularly bad at, and probably are still particularly bad at. But you mentioned not turning things off when you're done with them. There's a certain amount of discipline that comes with it. Even today, we find that a lot of the apps that are running aren't particularly elastic. If they're a long-running app, you're buying to their high watermark. And so I think that creates a lot of stranded capacity as well. I assume you've kind of seen that as well as people put legacy apps in the cloud.
When we first start on a cloud journey, you're right. First things that you end up doing is just taking what you have and bringing it to the cloud. And you start to look at doing some of the basics, right, of turning things off and making sure that you're on top of what you're running. Then when you start to look at the actual spend, one of the big benefits that cloud provided, I would say, is it uncovered bad design, right? I mean, no fault for anyone. It's just that you build something and you build something in the environment that you're in. You bring it to the cloud, you have this elasticity capability. You can't take advantage of it because you just didn't design the application in a way that could be elastic. And so that's the next level, is you start to uncover some of the design elements that you can use to take advantage of the cloud, like elasticity, like scaling up and down, vertical or horizontal. I always use the example of disk, right? When you're in the data center, you're always building out for a 3-year disk capacity plan, right? Where am I going to be in 3 years? Well, I don't know, but I'm going to get as much as I can, right? So I don't have to go and deal with the lead times of getting additional disk space, which again, it's not bad, but you also don't have that immediate expansion of disk space. And so you bring that same kind of concept into the cloud where you're allocating storage for what you think you might have rather than what you actually need. And so you end up overspending or over provisioning, even with compute, right? You think you might need 10 machines because you might see something down the road that the business wants to do, new clients, new customers, what have you. And so you sit with these 10 machines running idle just in case something happens, right? You kind of need to change your mindset to account for what the cloud can provide, which is this is what I need, and you can scale up almost immediately. You can make reservations. You use spot, right, and spot pricing to scale up and down if your application is able to support that kind of scaling. There's a lot of different ways to scale up and down and take advantage of the cloud that you normally couldn't do before.
Yeah, and so that's interesting because, if you rewind, there used to be, there was capacity management, there were capacity management teams, and, I think you put it well, they kind of had a major in making sure there's enough on the floor and a minor in making sure there's not too much. There was always that tension, but the primary function was to make sure you bought enough and have it in your data center because you can't get it for 3 months if you realize you don't have enough. So nobody ever got fired for buying a bit too much. In the FinOps world now in the cloud, it's kind of like a major in not having too much. You can always have enough. On demand. It's really flipped to be a lot more around making sure there isn't too much, which is obviously very challenging. But to your point, you can always have enough. You can just turn it on the fly. That whole new function is really with a kind of a different, bias, if you will.
That's right. AWS, the well-architected framework, when they talk about optimizing for the cloud, they talk about, aligning to your usage and utilization rather than being over-utilized or over-committed, because that's that extra dollars that you're basically wasting, right? It's just sitting there doing nothing, and you're not taking advantage of the elasticity cloud providers provide. From a FinOps perspective, from a cloud FinOps perspective, that you start to focus in on, and like you mentioned, roles that weren't created are now being created to kind of manage and keep track of those kinds of spends.
And we like to think of the world that there's the how you buy and the what you buy. Back to that early phase, it's almost like the way you describe it, it's almost like there was a buzzkill phase where you can't do anything you want. You got to get this under control because, a very junior engineer could buy infrastructure by putting a line of code in a Terraform file. So you kind of need to get that under control and then really focus on the, making sure you're not overpaying for things. And we found that there was a distinct kind of phase of focus on the financial versus more recently, focusing on the resources that you're buying. So there's the how you're buying. Am I optimized as far as my discounts and my reservations? Once that's all taken care of, well, then let's focus on the actual resources we're buying. Because if I'm using twice as much memory as I need or twice as much CPU, it's going to be expensive no matter how many discounts I have in place. So the first kind of buzzkilly thing, and then let's focus on financials, and then later more to what you're describing now, that let's make it elastic and get things turned off. In that journey of you've seen probably things that work and things that don't work in terms of getting people to optimize their resources. Do you have any kind of interesting experience in that area?
Oh, definitely. So a couple of points that when we go to talk to engineers, first thing as a FinOps lead, you need to understand is that the engineers have many, many priorities, right? And cost might be part of that priority list, but they just might not be as high because they're trying to get things done for the business, right? Application that we've committed to getting it done and delivered. And so I think the first challenge is how do you get the attention of engineering teams, of engineering managers to understand that, yes, this is important. It might not save a whole lot for your specific group, but holistically for the organization, for the company, it can save a lot, right? Because it's all cumulative. So one is getting the right information to those engineers, and then also providing the steps to take, right? Not just say, hey, you're overspending by X amount, or we see a sudden spike. But it's also going there, and this is what you can do, and this is what we've specifically found. You've allocated double the memory, but you're only using half of it. You've quadrupled CPU, but you only need 1/4 of it. And so those are the kinds of bits of information that you want to go to the engineering teams to say, not only are you over provisions or over capacity or went beyond what you really need, but here's the levers that you can pull to bring it back down without fear of the application falling apart, right? So as an engineer, and having started out as an engineer, I know, because you always want to make sure that the application still runs, right? Even if I went from 16 gigs to 8 gigs of RAM, is my application going to slow down? Is my application going to have issues? How do I quickly scale up? If I bring it back down and all of a sudden I see a spike, what's the impact of that spike? Starting from the other side, I kind of have the benefit of both sides of the table to a certain degree, is I kind of know what the other side's thinking when I go to them with some explanations. I've presented opportunities for right sizing, but without memory metrics, and the pushback I get is, well, I'm memory intensive application. I'm not even going to look at this. But you might want to dive a little bit deeper and say, okay, well, maybe there's another way to capture those memory statistics and see what's really going on, because I am really seeing really no network I/O and no real CPU utilization. Maybe there's something to go in there, but you don't want to force the engineering team to take that extra step, right? And to have them dive into something. You want to go there with all the information that you can bring, whether it's utilization of CPU, memory, storage. You allocated 10 gigs or 10 terabytes, but you're only using 1 terabyte. You can always scale up. You can't scale down, right? It's harder to scale down the storage. Another example could be the overall spend. If you bring this down, you can see that your application won't be affected and you're reducing your spend by X percentage. That goes a long way. And then allowing the engineering team. So one success area I did find is if you show the engineer how to find this information, use the tool to its ability, the engineers in some cases are willing, if they have the bandwidth, to go in there and dig around for themselves and find that. So if you share with them the information, they can tweak the settings themselves and say, oh, wow, this is something that's staying on that we should be turning off. Or finding from a list of 100 machines, identifying, hey, wait a second, what's this machine here, right? And so those are the kinds of aha moments that keep you going. Those little successes that keep the function moving, right? Because you're always finding those little successes, and those aha moments definitely make it worthwhile. But you also have plenty of, hey, go back to the drawing board, and how can I convince the other side that this is a good thing to do? Because when you get to a certain point beyond just turning things on and off, you get to a point where you might want to look at exactly how much you've allocated. And then beyond that, when that even stops working, you might say, you know what, maybe we need to take a step back, and this application really needs to be redesigned. That level of work is much, much harder, right? Because that's just requiring development resources that you need to convince the business to commit to and whatnot. So you generally don't go there, but you want to get ahead of the next round of feature development where, hey, maybe we shouldn't go the same route again. We should try something else in terms of an architectural approach. to the new feature or new product that's being developed that's more cloud native, for example. So it's hard to take legacy applications, bring into the cloud, and then make them cloud native, because that's just a lot of development effort. But if you start something new, think cloud native, right? And that will get you there a lot quicker in terms of more efficiency, more optimized environment. Or you can say, let me do some tweaking before I move over, right? To take advantage of some of the capabilities that the cloud provides. So you get to that level of thinking as you spend more and more time in the cloud space.
It's pretty expensive to rewrite an app. So maybe your crown jewels, you might do that, but a lot of apps are going to kind of ride off into the sunset in their current architecture. But, what you said about convincing engineers, I'm an engineer too, at least my training is, and I know exactly what you mean, that the data is so important. I remember in the early days of cloud, we used to say, what something's running on shouldn't be a matter of opinion. The data and analysis will reveal exactly what you should be doing. There's not really any leeway there. It's not like opinions matter. And now we still find that the data is so important. If I tell you, here's a recommendation to do something, and I don't, show my work, you don't know what the basis of that decision is. But if I show you all the curves, all the metrics, the policies, we've looked at 95 days of operation and you've never gone above that, then people are more likely to trust the answer. And because it's the engineer's role to keep the app working. It's their job to not take an answer that might have an adverse effect. So I totally get what you're saying about and really it's a very data driven approach. And I think it becomes more and more so as we move forward, where there's more moving parts, more instances, and things like containers, which can be so complicated. You'll never figure them out unless you have, the right data and the right visibility into what they're doing. So let's talk about containers for a second, because, we focus on them a lot. We think they're coming. And when you talk about rewriting apps to be more elastic or to be more next gen, a lot of times now that's, going into the container world. So are you seeing containers rise? Are you excited about containers and where they're going?
Containers are interesting. There are decisions around, okay, I can containerize something or I can go serverless, right? And serverless is an interesting thing. Not everything is going to fit into serverless and not everything is going to fit into containers, right? What the application is trying to achieve, right? And what the environment calls for. Yeah, containers are interesting in the sense that you can fit a lot into the underlying instance that's running the container. And you also have things that are serverless containers, right? Like Fargate, right? But they limit memory and CPU, right? To a certain degree in terms of how big a container can be. So there's a lot of decisions up front that you want to make before you jump right into containers. And then once you're in the container, you also want to see how much, again, memory and CPU you're actually using in that container. So if I allocate a container 2 gigs of RAM and 1 CPU, but the container is only using a tenth of it and maybe a quarter of the memory, and that's still waste, right? That's waste that the underlying system has to support. You want to have the ability to monitor containers just like you do servers and EC2s and EBS volumes. And I keep referring to AWS services, but this can apply to any cloud environment, right? And you still want to be able to monitor containers. You want to be able to monitor them just like you would anything else. And so having the tooling in place to help you monitor that, whether it's third-party, homegrown, it's really important. And you treat it just like anything else, right? You treat it can be scalable. You want to be able to scale up and down or up and across. So vertical and horizontal scaling for containers.
These containers aren't using virtual resources. They're using real resources. So if I give a container 1,000 millicores, I can't also give those 1,000 millicores to another container. They'll share at runtime, but when you're scheduling them on the nodes, you get your CPU. And I'll stop using that node when I've given out all the resources. So people coming from a VMware background where there are virtual resources, that's not the same way in a container environment. So if you oversize things, it very directly impacts the efficiency. It just locks up those resources and strands them almost immediately. So, we see quite a bit of that. And also for like a highly replicated service where, the replica set, there might be hundreds of them running, any error is multiplied. So we've seen cases where a single container manifest is responsible for, hundreds of CPUs of waste. So, to your point, the same techniques, I totally agree, you need to apply where you need to actually keep on top of these things, but there's a whole lot more of them out there. It's difficult. It's like almost at the process level now, you need to track those things.
Yep, I totally agree. Like you said, the volume just increases that much more and it just becomes that much harder. Really need to stay on top of that because that's the kind of spend that can really creep up on you. if you're not watching and monitoring.
Yeah, and it can creep up because somebody else is getting the bill. Often the team that's deploying the containers isn't even getting a cloud bill. They might not even know what nodes they're running on. So it just shows up as a giant scale group, to use Amazon terminology. So it almost comes full circle to the start of our discussion, because you talked about people not turning things off and making the point that there's lots of ways to scale, and there's a lot of native structures for the different services that you can leverage to make sure, because we've seen that too, where the scaling's inefficient, and that strands a lot of capacity as well, because there's too many things running for the workload, and making that come down is as important as making it go up. Like, you can get bigger for new load, but you have to make sure you stop using it. So it's almost like the new form of the problem you mentioned from 10 or 12 years ago, where instead of just leaving an instance running forever, now I have some more sophisticated structure running, but it's also not getting smaller when it needs to, or bigger when it needs to. It all comes back to that promise of elasticity. And if you configure it right, then you're going to have great performance and a fairly low bill, because you're actually stopping. So things like Fargate, the serverless, all these things are pretty good at that, because you kind of use them when you need them, and then they inherently go away.
Right. You need to build that trust factor with the engineers when it comes to a FinOps role, right? You need to be able to come to them with data. Scaling up and down, that's what I want to get to. So scaling up and down, it also involves an engineering fear factor of how quickly am I going to be able to scale something up? And so that's the thing that you want to kind of get over, a fear of, or we need to decide as an engineering team whether you need to, again, is it a rebuild or just a rethink of how you scale? Because if what you're scaling takes a long time to come join the scale group, if you will, right? If it takes too long, then scaling just doesn't work, right? Because by the time you've introduced all those servers, the spike or what you needed to scale for is gone, and now you have all these instances running, they're doing nothing, and now they're going to go back down. And then the question becomes, how long do you keep them running before you bring them down, because you don't know when that spike is going to come again. That's something that basically you just need to monitor for and you need to account for. And then you need to think about the design of the application, not necessarily recode anything, but what are the things that you can break up, and what are those core things that need to run and come into the environment very quickly to handle what you're experiencing. And I think that's one area that we still need to work on, right? It's how do you scale up quickly? What do you need to scale up quickly? And how quickly does it need to scale up in order to service what you're servicing? I think that's where the challenge comes in when you're going back to FinOps and working with these engineers and earning their trust. When it's not just that, but then you also want to be cognizant of, hey, you only need 2 machines running. And oh, by the way, this application can quickly scale up to meet the last 10 spikes that you've seen across the last 10 months, right? Mm-hmm. So again, being very data-driven with that information.
And very dynamically solving that same problem of making sure you have enough without having too much. You've been talking about the warm-up time of these things. It's the engineer's responsibility to make sure it's warm and ready to go so you can perform well. Then ideally things would turn off when you don't need them, but that's almost somebody else's. If you're not seeing the bill, that's somebody else's problem. You can leave them big all day long if you don't care how much it costs. So there's still that kind of eternal struggle of cost always factors in, even into performance decisions, because the only reason you wouldn't make things huge is for cost. So we're probably stuck with this struggle forever, in different forms. And now it gets into more and more sophisticated structures and more elastic cloud structures, but it's still having enough without having too much. And as we talked about, the FinOps teams really are, tasked with making sure that you're not being wasteful, but it's really the engineers that are making sure that you have the performance. So we still have this kind of split situation.
Yeah. I think, like you said, it's good. It's just going to be there as long as I can tell, right? I don't think there's maybe down the road the systems can do it themselves, right? And the systems are sophisticated enough, the cloud providers are sophisticated enough that they know to scale up and down as quickly as possible. So at least as far as I can tell, I think it's just going to be a constant struggle between cost and performance and making sure that ultimately your customers don't experience any kind of lag, right? Any kind of poor experience on it.
Mm-hmm. Yep. Data is the key. Understanding, analyzing that data, making informed decisions, objective decisions, and not having opinions creep in is the way forward. Again, especially, like talk about containers, because you might have hundreds of thousands of containers and there's no way you're going to manually figure that out for those things. You need to kind of have the data and the machine figuring it out for you. So that's kind of hopefully the future of where all this is going, and everything will kind of optimize itself.
If you think about it, the role of FinOps has gone beyond just being dollars and cents. You almost need to be a data scientist to digest all this data.
And it probably leads to roles. I mean, again, just going full circle again, being a cloud engineer or a cloud optimization expert didn't exist 12 or 15 years ago. FinOps didn't exist. That's all kind of new. I wonder, where this is going. What's the next title that is going to appear in our industry that doesn't exist today in the next 10 years?
Yeah, it's wide open. I think where we are today is a much more sophisticated FinOps role. And I think it's only just going to get that much more sophisticated as time progresses.
Maybe we're going to see elasticity engineers out there or something. Thanks for joining us today.
Thank you. Thank you for having me today. It was a great conversation. And hopefully, we've enlightened a few folks.
Thank you for listening and joining us today. Really, really appreciate it. We have some excellent content coming your way. So make sure to subscribe to the show so that you do not miss an episode. It's easy to do. And of course, we'd love to hear from you. Densify.com for more information. And make sure to send us some questions if you have any. If you'd like to be on the show, email us at marketing@densify.com. Have a smashing day. We'll talk to you in the next episode, and we are signing off.